volume. Okay, that should be fine. Starting. Is that really the best quality? Oh no, it looks pretty fine. Streaming quality's bad. What? Is my mic fucking dead? Hello? It's not dead. Why can't I hear myself? What the? What is this? Here we go. Listen, now I can hear myself. What the fuck? Okay. I think it's time we get some work done. Alright, here we go. Timer is started. And let's brainstorm some ideas real quick, guys. Okay, oh, I didn't mean to make that a CPP file. Okay, so the goal of this game is it's gonna be a fighting game, okay? And I want to spend like around like 5 minutes planning this out, max. So based on my timer. Alright. So the minimum goal I want is like 1 boss fight. But if we do that, then we have to have, but in this case, we have to have really good movement, animations, I don't know how to spell that. I spelled that way wrong. And just feels. There we go. We have 1 boss fight. But my goal would be around 3. 3 boss fights. We have just 1 really easy one. 2 is like a medium. And whatever. I don't know how to spell that. And 3 will be like hard. But that's my goal. But I don't know if I'll be able to achieve that and be able to achieve this and then have this achieved while also doing that. That would be pretty hard. So what are the systems we need? We need our opengl. We need an animation system. I'm really scared for animation. That's the thing I'm most scared for because I suck at animations, and you know my OpenGL knowledge isn't that good right now. But once I learn how to load some textures up with the shader, I should be fine. I could crank out some animations. I guess they don't have to be that good. Animation system, movement. Can I spell anything right? Movement, combat, and like health. We don't have to worry. I think that's the bare bones. We need animations, movement, combat, / damage system, and we could have it so like the player or our player only has like 1 item, and our player only has 1 item, and they have to fight. There is no progression, but our bosses will have multiple, just different attacks and styles, forcing the player to adapt. So we could. Why is it doing that? Why did my mic cut out? That's kind of crazy. I don't know if that's YouTube or that's me. We're about to find out. Mute this. Okay. Okay. I hope my mic didn't cut out just then. Turn that up. Up, up, up. Okay, yeah, I think it was just YouTube. I don't think my mic actually cut out. Oh. Yeah, okay. Okay. It was just YouTube. Alright. Okay, let's get. So I think this is a good plan. We could have 1 boss fight really good, 3 boss fights between easy, medium, hard. So we can pick from one of these 2. we could also, and these are I think the main systems that we need, to be honest. And our player will just have like one item, like one sword or something. So we don't have to focus on any progression. We just focus on the bosses where they only have to fight. I think this is achievable within like 72 hours. I think that would be good, and capable with my abilities, given my like circumstances. I'm just really concerned for textures because I haven't done that yet, which I probably should have done that before I decided to, you know, take on this challenge, but it's whatever. We'll be able to do it. I am wasting a lot of time though, but I need to set up one last thing and then we should be good, and then I can just get working because I already set up opengl and like included and linked everything. I was trying to use VS Code and like I could never figure it out, so, which is a shame. I really want to use VS Code. I thought it would like make me better, I just understand stuff more, but it did not work out. Where is this? Jesus. Over here we go. Nope, that's not what I was looking for. What the fuck? Oh, I can't do that. Whatever. It's fine. Okay, 7 minutes. 8 minutes down the drain. It's okay. Time to boot up my favorite Learn OpenGL. And let's get that started. I'm going to dox myself if I do that. That would be not a good idea. Because I don't want to have myself... Okay, what the fuck? My mic is dying out. What the hell? Is that my... What is this? Oh my god, it's my headset. It's my headset this entire time, or my earbuds. They've been bending awkwardly. Okay. Whatever. Alright, here we go. So, Learn OpenGL will carry us through this task. I haven't used OpenGL in a little bit, but I remember a good amount of what I use, because I've been focusing on other projects not related to game programming, because I had a like existential crisis, like, oh, why did I just type that? If I don't learn how to program something other than games, how will I make it in the software industry? And I was like, I can do that. And then I went off on a tangent and I made that text editor. But, which was fun. I liked making that text editor and it was pretty cool, but, you know, what? Oh my god, I'm already having errors. What the heck? Oh, it's because of this. This is a TXT file, bro. Are you serious? Whatever. Shit. There you go. Now will you work? I made sure that this built. Okay. There we go. All right, so we're 11 minutes into this challenge, and we got Hello World printing out. All right, let's get this window. Let's finish this back end because I'm sick of this, of having nothing done so far. Okay, so let's keep that hello world there. That's nice. It's like you do the window hint stuff, GL window hint, GLFW, context, version, major. We're doing 3. Then we gotta do the minor. And then, like, the last one is, like, it's, what's it called? I'm trying to remember it. I could just tap out and go to the stupid wiki, but I remember it. Profile. GLFW profile. OpenGL profile, like core I'm using. And then GLF profile, core profile. Right? GL open, whatever. Let's see if I got it right. Yes, sir. That looks right to me. Oh, I forgot the init. Oh, that's okay. Okay. Now, I need the GLF window. Call window. You do this. I'm just gonna copy and paste it. I don't really care. You set my viewpoint. Take this stupid function. Go. Do this and then do GLF. Oh wait, did I do current content or set current? I guess I can't do that. What do I do to set the window as the current constant? Here we go. This glf make constant window. It's kind of dumb. All right, let's see what happens. Failed in it, glad. Glad is enabled. There we go. Easy. The only reason why I remember to do that is because I've had this happen to me so many times. Glad is done. Time to go down to here and set while pretty sure glf pull events and then glf swap buffers. I think that's the order. Let's check if I got it right. No, it's the opposite. It's the opposite. There we go. Now we should see our window. There we go. Window is accomplished. All right. All right, so we got our window. And then at the end, we gotta do like glf terminate, glf destroy window. I think we have to do destroy window. I don't know if that makes sense. See if they did that. Oh, they didn't. It's okay. All right. All right, what color do we want? Oops, I don't even know what I just did. That didn't work. Why did that not work? Oh, that's clear color. Wait, no, that was right, but I just had to put this. It's okay, it's okay. I'm warming back up. There we go. We got our blue. I did not expect that color, but it's a pretty nice color, so I'm happy. Alright, so the window is done. We got our window done. Next we should set up our shaders. Because that's the next step. But I'm gonna have to pull up my laptop here. Oops, sorry. Pull up my laptop here because I have a preset project on this already. Actually, it'll be more fun if I write it myself. I don't care. Time to write beautiful. Shaders. Okay, so we're gonna need to make a separate file where we can put our shaders. So shader stuff. Okay, I'm gonna stop popping that squeaky metal thing. And classes are evil. So we are going to need to be able to write files. So let's create another thing. Oh, not CPP. A header. Alright. And this is going to hold all her yummy data. Let's destroy my type, or display my types. I don't know why I didn't name this. I'm just gonna rename this to like base or something. Or types. Go. Type def. Let's get our unsigned int 32. Is that what unsigned int is? We're about to find out. Okay, can you stop? I don't think I have to include IO stream for this, do I? I do. Silly. Let's just have 128 just to have it. Oh, that's not a thing. I thought it was. Whatever. Alright, here are our basic types. Now we can go into our shader. Just go ahead and include our types. And let's make a function which returns a char pointer, or I think we can do that, right? Yeah, no, you can't. Oh wait, because I put void. Why am I doing that? Nope. Oh, whatever. A char pointer. Are you serious? Oh, whatever. Parse shader file, or file parse shader file parse called source file source. Yeah. See. Can I do that? There we go. Here we go. Alright, so basically you want to just read in that file and just write it out to our string, which we gotta create now. So okay, bruh. Just thank you, Geeks for Geeks. I love this website. I understand what the file types are. Just tell me how to write it. I just want to write to a string, bro. Chill. That'd be written. Okay, I wanna be read. There we go. Read. You know, let's just be honest. I am overcomplicating this, and let's just use C++ version. There's no point in doing that. And let's just return a string. Close that. You have to include fstream. And let's just return, yeah, constant sharp pointer. That'll work. Let's just create we need if. There you go. Oh, that broke. Why'd that break? Okay. Here, just keep it like that. Go. Are you serious? Why is that not working? std get line. Oh, do I have to include string? Yeah, that's why. Wait, what? My text. So let's see if I can just whatever. Okay. Oh, you know what? I'll just do my ideas thingy. Sounds like a good idea. Include my shade. Oh, that's why it's not shader. And let's use this as my example. Why would it not? I don't know why it wouldn't autocorrect for me. Alright, let's see what happens. See if I did it right. Yeah, I did. I guess I didn't do it right. Oh, shader file parse. What'd I say? Shader file parse file. Oh. Why is it not autocorrecting? What is going on? That's why I hate Visual Studio. Oh, that's I'm such an idiot. Never mind, Visual Studio. I take it back what I said about you. There we go. I don't know why I was doing that. And then I just named it the same thing. Just name it test. There we go. Okay. I see it didn't include my new line characters. That's okay. How about every time we add a new line character at the end of it? Now it should work. There we go. It looks pretty good. Alright, so that's, oh, what I just closed. I'll figure it out in a second. Okay, so now we got our shaders getting parsed. So we need to now write the shader compiler, which is gonna suck. I hate doing that, but it's okay because I already have a pre-open thingy to write that. All right. Here are the functions we're gonna need. I also need to install GLM, but I'll do that sooner or later. I'll do that after I'm with the shaders and getting ready to program actual gameplay stuff. But I need to pull up my laptop and find how I wrote my shaders, because I forgot. I haven't done this in a little bit. I just need to see how I wrote how I compile the shaders and error check it, which I could do with learn opengl, but I'll just do it with my laptop, which is open right now. I like how I'm already like 35 minutes into this project and I don't even have my shaders working yet, which kind of sucks, but oh, well. Oh, here we go. There we go. All right. Shader underscore compile. Spelled compile wrong. we have to pass in the type, which is the type of shader we want to compile to, and the source. There we go. So now we can go into my shader, and let's get this knocked out real quick. I have to include, what was it? Is it glad? Pass in the type, or where we actually want to put our data in, our ID, how many we want, the actual file we're compiling, and there you go. And then we need to GL compile the shader, and then just return the shader. So we just compiled right here, and now we're gonna error check. So we can just say end result GL get shader IV ID GL compile status, and write that into our result. I need my length. I skipped this step. You need to allocate this kind of buffer or this string so we can actually write it into our thing. I keep putting dots. I need to stop doing that. It's making me angry. There you go. Take that. Address. And then we can just, I don't think I have IOStream included here, do I? Oh, I do. Error. Failed to compile shader. And just and then we just need to delete our shader because it's not even working, so why would we keep it? And then return 0. Alright. Alright, okay, we're doing good. So we have the actual file reading process. And now we just need to curate our actual shader here. Here we go. Okay. I signed in, call it program, GL is equal to GL create program, vertex shader is equal to compile, VS is equal to shader compile shader underscore verts, and then put GL shader frag or GL fragment shader. Go down to here, do shader underscore frag GL. Oh my god, that would have been really bad. I just named this fragment shader. Vertex shader. Okay, I need to autocorrect. There we go. GL vertex shader, and then I need my GL fragment shader right here. Okay. That took me, why did that take me so long to type those, like, 3 lines of code? And I named these the same thing too. What am I doing? Okay. Attach shader, program, vertex shader. Do it again for our fragment shader. Link our program. Validate it. And then just delete our shaders because we don't need them anymore. Vertex and fragment. And then we can just return our program. Go. So that is our shaders done. Or our basic shader. Now let me organize this just a little. Go. And now I can create some shaders. For now, this will just be player. Here, vert shaders, and then I'll do frag shaders. So this will be our player frag .glsl. and player vertex.glso. Okay, now we got a program that just shades, and I haven't done that in a minute, so. Let me just copy their basic example. Vertex. Version 330, we're going for core. I'm in my fragment, right? So let's just gl frag. Is it color is equal to vec4? Like, what? I think our little triangle should be. I feel I'm lucky with red. There we go. Is that 4? 1, 2, 3, 4. And we have to like take layout. I forgot how to do that. Layout location 0, and we're gonna take in like I think our position. Yeah, vec3 called pause. Oh wait, I'm programming the fragment. Why am I taking in a position? That doesn't make any sense. Yeah, exactly. I don't need to do that. I was like, what? We just need to output our fragment. I thought I could do that. I guess not. Whatever. Alright, is that good? Oh, I need to add the vec4 right here. Out of vec4 called frag color. I guess I don't need to include this part right here. We're gonna make it red. And then let's go. Now let's just program our vert shader. Again. 330 core. And then now we want to take in that vec4, which is going to be located at position 0. And take it in called vec3 called pause. And gl underscore position is equal to vec4. Can I do that? Yep. And this will be equal to a underscore pause 1.0. Okay, so that's our two shaders done. I really thought you could just do GL frag color. Am I wrong? I don't think I'm wrong. Yeah, no, I'm not wrong. I don't know why they have me doing that. You could just say GL frag color. We're about to be an hour in, okay? I just got my shaders coded up. Let's actually get this done. So I'm gonna take these indices right here. What are these vertices? Because I hate manually putting in vertices. And we can delete that test code because we know my program actually works now. And let's get this GL backend done. And I'm gonna take a break and then come back and finish and probably import the math library and get a basic shape moving around. Because it's kind of honestly embarrassing that I haven't done a lot of this yet. Okay. Now let's get this rendering backend done. Or the basics, just for a triangle. Struct called buffer. I don't know. I don't remember. Let's have that struct called buffer. Then we can go. I need to. How would I just include like a rendering file? Put this in here and just delete this. That'd be. Yes, I understand. No, don't do that. And then create buffer dot header. And include our types. Have that struct called buffer. We're gonna need its ID, which I'll just call buffer. We're gonna actually need its type, count them how many we want, and then the size of it. Okay. And let's create two functions here called buffer init, which will just pass in buffer. Let's actually. This will stay here. Close that down. Same thing here. Render. Don't capitalize that. Render. Put this folder right here. Buffer. And let's have that buffer.cpp. Buffer. Now we can include our buffer header. And now let's create this two functions. Void buffer init. And we'll take a buffer pointer called bf. U32 called type. U32 called count. U30 and then a size called size, and then a void pointer to the data that we want to pass in, and the actual usage of what we're using this buffer for. And then we need to want to create a function that just binds our buffer. And we'll just pass in this data. So no need to do anything else. Data-oriented mindset. Data-oriented. Data-oriented. We can close that down. I don't need these two anymore. Alright. Now I can init this buffer. Buff count is equal to count. Buff size is equal to size. Buff type is equal to type. GL generate buffer. Oh, I need to include GL. Include glad. Here we go. Now GL. And we want how many buffers, whatever buffers we want, and then we need to write to our buffer thing. Then let's bind that buffer. Type and our actual buffer. Oh wait, really? There's no way. Well, good thing I never got an error from that. The fuck? Pass in the actual buffer we want to bind. So that's how this works, right? GL gen buffer. How many buffers you want in the actual buffer. And then GL buffer data. We can just set to type, size, data, and our usage. And then here in the actual bind, we just say GL bind buffer, and we put in our type and our buffer. Here we go. So our buffer is done. At least it should be. So I can remove this. So now that's nice and organized. Go down to here. And let's get this finished. Oh yeah, let's get our indices rendered too. See, I just want to copy them. Give me the indices, please. Thank you. Actually, I don't need to do that because I'm not rendering a square. Why would I copy the indices? I'm an idiot. Okay, and now let's create our two buffers. Buffer call, and that's going to be our buffer, vertex buffer, which is equal. All right, and then we're going to create a vertex buffer and an index. Well, we don't need an index buffer. We're not using indices, so it doesn't matter. Vertex buffer, and we want a vertex array. Then we need to actually generate our vertex arrays. One, pass that. Yo. Buffer init. We want to pass in our vertex buffer. Vertex array buffer. One, size of vertices, and we want to actually pass in our vertices data, and it's going to be a GL static draw. Okay, and then we need to create our vertex attribute pointer, which will actually tell OpenGL how to read our array. We're starting here. Wait. Why am I using 3? God damn it. Fucking idiot ass OpenGL people. I'm making a 2D game, not a 3D game. We start at 0. We run across 2 of them. Every time we hit 2, go down. what the fuck? I didn't go down, I keep going. Good job, OpenGL. We don't want it normalized. Our stride is the size of a float times 2. That's how long our data is. And 0. There we go. Okay, so now we should be able to curate, actually see our triangle. Alright. Generated our vertex array, created our buffer, created our attribute pointer, and created that. We didn't create our shaders yet, which we need to do. Just call this shader basic, which is equal to gl create shader. Oh, no, whoa, create shader. Shader underscore create. And we're gonna need to send in our parsed we're actually gonna need to send in our parse shaders through this parameter. Which one do I do that? Whatever. Shader parse file parse. What was what I named them to? Our player fragment .glsl, and then we need to send in, oh, that's backwards, and send on our shader file parse of our player vertex .glsl. That should be it. Now we created our shader. And that should be all. Then I just have to go down here, tell OpenGL use program our shader basic, and then I don't remember how to do the last part. It's this geo bind buffer. Well, that's with indices. I don't want to use indices. Here we go. And boom, VAO, and capital. All right, now if I did everything right, my triangle should pop up. I don't know why it wouldn't. I mean, created the shader, created the buffers, gave it the data. It's been an hour and 5 minutes. So let's see if I manage to get the basic setup. And I did. Oh, that's why. What is this? Fail to compile a shader, syntax error, undefined token, undefined. Fuck. What do you mean? Oh, well, I mean, I have my triangle. It's just my shaders are broken. What are you talking about? Am I not supposed to put the hashtag? I thought I was. Am I not? I am. Put the... Why is this breaking? Here you go, here you go. Okay, so we have the triangle. Alright, so our index buffer is working. It's just one of these shaders are failing to compile. But why? Let me just look it up. What's the worst that we can do? Stack Overflow time. The error match to print, that means to share compiler seeing garbage character, seeing a garbage character. Oh. And that's what I get for trying to be fancy. My stupid parsing file didn't work the way I intended it, which is fine. Whatever. It's just parsing wrong and giving me a fucking tangling pointer. I know it's probably happening. It's just like, oh no, you can't do that, because then I'm gonna destroy the string you gave me. Which, good on you. Do that. I don't mind. And the thing is, it's because I'm going into here, right? Alright, here we go. Here we go. This is, I know what's happening, and I'm going to explain it right now to anyone who cares, or anyone watching the vlog, because no one's watching right now, which is kind of embarrassing to say, but I'll admit it because I'm not. I'll admit it because, you know, you gotta do what you gotta do. So we got this const char pointer right here, and if we try to do my file parse thing, right, and I pass in my ideas.txt. So what's happening in this function? How do I go into in VS Code? How do I like just go to a function? Here we go. There we go. Wait, what was that? What was that hotkey? F12. Whatever. Okay, so what's happening here is I'm reading this text. I'm declaring this right here. Okay. So since this is on the stack, what is actually happening? What I thought would happen is when we leave this function, we copy the contents of the data into that variable, which is what I thought would happen, which I think should what happen, because, but if it's not, then that would make sense, right? So if we run this, we can see right here that this text file came out good, right? It ran it out, fighting game, min boss, fight really good. All right, so we know that just happened, and the error is I'm pretty sure that our string right here, and where is it? Our string in the parse file is getting thrown away, and when we return it, we're just returning a bunch of stupid data that's not real, which my suspicions will be confirmed if I can't print this out right now and I get an error. But if I don't get an error, then I give up. Yeah, see? Okay, I knew it. So, what's happening is in this function, we aren't actually copying the data. We're just trying to send data that doesn't exist, and when we leave the function, what's happening is that data is getting deleted because it's declared on the stack, and it can detect when we leave a function and it should get destroyed and the memory should be reset. So when we're going and we're just passing in this copy of it, it's not actually copying the data. We're just sending in data that doesn't exist. So when the stack destroys it, when we get out of this function, we are not actually sending in anything useful. So I could fix it by just passing in a string, but I'm not going to tap out like that. I'm going to add a string. That's what I'm going to do. I'm going to try a pointer. Okay. Screw the constant char pointer. Okay, let's get rid of that. It's not constant no more. No. It's a char pointer. And then we're returning. We're making a char pointer right here. Or here. Oh, well, because I don't have to. You know. Wait. Stop. I'm going to try something real quick. So I know this is not going to work. But I want to see if I can see the size of this text variable right here. Can I please just hit keys correctly so I can make this a faster process? Size of text dot copy to string. I don't know how big it should be. 8? Okay, well, we know that's wrong. It's not 8. What about if I just do this? I can't do that. Actually, I can. I just have to add this. $40. Okay, that should be right. And if I pass it. 40. Wait. 40. 40. 40 everywhere. That's not right. Alright, whatever. I'll just use strings. I don't care. Fine. You win. You win. I could figure out a way, but I don't want to. Just return a string. Wait a minute. I'm a dumbass. That's it. No, I'm not giving up. I'm not giving up. Neither I'm using strings in my function, but I'm not giving up. Because I have a feeling that I'm actually, my thing is just not printing at all. That I'm not actually adding any data to it. That's my new theory. Okay. So here we're gonna say before or after file or read. Print that out. And then say ending or whatever. And I can get rid of this. Alright, so let's see if it saves. Oh, that's cool. It didn't. What the it only saved the end? Why'd it do that? You make my life so difficult, dude. I thought, whatever. Do I just not know how to read files in C++? Am I just an idiot? I know a way I could do this, but I just don't want to do that way. I want to just figure out why this actually isn't working, and I'm an idiot. After file read, it only saves the last bit. So as we go through this file, I just want to read in all the text. Okay, that's all I want to do. So yeah, that does make sense because I'm sending over the data off the stat. Like I kind of knew that I was like talking shit because that doesn't make sense, right? We have data right here and we send it off and we're like, hey, we're not. I don't think we're passing a pointer, are we? Oh wait. Oh wait. We are. Oh, never mind. That makes sense. Okay. Yeah. So we're passing a pointer to the string that we dereferenced. So never mind. Well, what is a problem is that our data is not saving. So to fix that, let's do something like this. Here you go. And then every time at the end, we insert our text. There we go. Now this should work. Now we should see no change. There you go. There we go. Now it's working. After file read, it reads all that. And there we go. Beautiful. Beautiful. And I can just stop printing this out. There's no need to do that. And then to prove that it worked, we can just say text right here and see that it didn't work. Oh, whoa, what the? Yep, see, and then right here it's broken. Alright, error fix. Let's go. Easy. Easy. And now, to further prove my suspicion, we pass in, or we send out the text.final, that pointer to that char array, and it should still not work because that char array is getting deleted that we're pointing to, so it's invalid memory. And this will make sure that I'm a god programmer. Exactly. Exactly. Okay. 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 I'm sending out garbage. I knew it. I knew it. I knew it. And now what we can do is instead of doing that, we can just see out length of string, which we can just use text final.size, and whatever that size is, and we can just create a char pointer with that many bytes in it. 314, yeah, that makes sense. 774 makes sense. So now what we can do is we create a char pointer called, and I don't want to return a constant anymore. No more constant. I'm done. Just a char pointer. So now what we can do is return a char pointer called final text called string, which is equal to, and wait, we don't have to do this, do we? Can I just like right here, I can just do std string called text. Pretty sure I can just do that, right? No? Oh, well, I'm an idiot then. So this can go right here, because this doesn't matter. Pass in the text. We're adding it. We get the size. We know the size, so I don't need to do this anymore. And then we can go string is equal to malloc, or first of all, cast it to a char pointer. Malloc size of, or size of char, which is 1, right? Chars are 1 times text final dot length. There we go. And then we have to copy the data into the string. What the hell? God damn it, I'm not good at string manipulation. I'm overcomplicating this, but I don't care. I don't care. I'm gonna make this work. I need to copy that data into okay, dude, I don't need an article, bro. I don't need an article. Here we go. The fuck? Coordinate. Oh, combines them. I don't want to combine. Thank you. I just want to copy. Copy string 1 to string 2, so it should just print out hello world, which it will. So we should go down to here. And string copy. Wait, is it string cat or string copy? String copy. X dot copy. String, and then our text final dot c length. There you go. Now we can return our string. But before we do that, actually it doesn't matter because I'm gonna get a bunch of errors. I'm pretty sure. Yeah, okay, I knew it. Here we go. Wait, what? Are you serious? Whatever. I don't care about your warning, dude. How do you disable warnings again? This one I like. Suppress doesn't work. There. Stop. Don't tell me what to do. There we go. It works. Yeah, I didn't get any errors. Okay. But now we have more memory allocated. So what do we do to those char pointers we have now? Well, young viewer, thank you for asking. We create a char pointer called player PV, okay, which is equal to this right here, and then char pointer right here called player F, which should be fragment. Boom, okay, and then instead of passing in this, we pass in PV, PF, and then we free PV and free PF. So now those don't matter anymore. And we can also get rid of this because we don't need to test it anymore. There we go. Bug fixed. Oh shit. Never mind. Not bug fixed. Not bug fixed. Okay, I'm sorry. I'm sorry. What happened? What'd I do? The hell? happens if I just don't free it? That was really embarrassing. I just go, oh, bug fix. Okay. Okay. Oh, well, I only have 56 bytes allocated. It's fine. But I do want to get rid of these because it's returning a char pointer, right? So now this is allocated. And I want to get rid of that. Can I not get rid of it? I mean, I create the shader, right? And technically, I don't need these anymore. So why can I not free it? Free PV. Heap interacted at block 16 at Sierra detected application wrote to memory after end of heap buffer. I wish this wasn't live. I would cut it out. I would totally cut it out and make it look like I'm a genius and I know what I'm talking about. I never free the meshes either. Wait, do you have to free char pointers? Because technically I should have freed the message too, and I never did that. Well, how do I try to free the message? Do I die? No. So I free the message after I print it. So what am I using? After I do this, what am I using? I compile. I create it. I compile. Because I shouldn't be talking about this message anymore. That needs to be free. That's a memory leak right there. And that's obviously my fault for using stupid pointers. And you can yell at me all you want. But why? Whatever. I got to my goal. Okay, and with an hour and 30 minutes, all right, whatever, dude. I haven't done this in like a month, so, you know, I don't really care. We got the red triangle, okay. We got the red triangle. We got our file parsing system working, which we can also use in turn to parse other, like other systems and file text or whatever. So I consider this a win. Boom, there we go. Alright, triangle done. Beautiful. All live too. Amazing. I just wonder why I'm not allowed to use my destroy the PV anymore. You know, let's see what happens at the end of the program if I try to free PV. Oh, it worked. Oh, wait, no, I have to press the exit button. Okay. Okay, I don't understand. Alright, whatever. It doesn't matter. It works. Hour and 30 minutes it took to get us all set up. But considering that I haven't done this in like a month, we're chilling. Okay, we're chilling. You know, it's working. It's working good. We got our shaders done. We can actually work on... Let's change our objective here. Because this needs to be changed to what we're actually talking about. Now, the next step... Let me change this. The next step is to make our GLM or make perspective. Basically GLM, which I should be able to do pretty quick. Honestly, all I have to do is just import the GLM math library, and then after I do that, just already have preset aspect ratio and everything that already works for me. But after I do that, the thing is I need to work on textures. Maybe we should work on textures real quick. Work on textures and then work on the perspective. Alright. That'll be a better idea. But that's gonna be an actual challenge because I haven't messed with textures in OpenGL. So I know I'm gonna have to learn that real quick, which might not be a quick process. But after that, then we can work on perspectives and scale everything to the correct ratio. And then we can start gameplay because I'll have textures, then perspective, and then I can do, after that I can do animations and the actual gameplay movement, which is my goal. So this will be changed to textures. So that's what we're doing next. So it's time to actually get researching on how to do that. But first, so let's bust out that OpenGL. So I should honestly, how long is this article or this section? Oh, these are comments. It's not that long. Alright, we should be fine. I should be able to do this pretty quick. Okay. Plan to add more detailed. Oh wait, you know what? I need to add indices real quick. Just get that set up. Get the indices set up. Let's get a square going. I don't want to figure out how to make a stupid Actually, I don't need to do indices. That's a lie. I'm not gonna do that. Let's just do the triangle. I already know how to do indices. I need to spend my time learning textures because I don't know how to do textures right now. Okay, let's see if they will provide us the link to a brick wall. I will take that, which I will go over here to do. This can go into the project. What I name this project? Fighting demo. There we go. I'll just paste this in here or something. Whoa. Oh, shit. I don't even know if I saved it. I didn't. Save image as fighting demo. Save. There we go. It's done downloading. Oh, shit. That should be here. There it is. I will organize this in a little bit, but right now I'm chilling. I don't want to organize this. After I get textures and everything working, then your boy will organize it. But until then, no. We're going to keep it a mess. It's not that big of a deal. Not a good use of our time. Okay, I guess I didn't like how I did that. Oh. Yeah, sure, I don't care. I don't know if I was supposed to do that. Okay, I don't care, I'm sorry. Let's keep reading. We got the file. We got the image that we need to use. Okay, I need to stop creaking that pole. Jesus. Each vertex should have a texture coordinated. Okay. Alright, so here's how the texture maps work. It goes from bottom left to top right. 0 to 1. 1 to 1. Okay, so you actually need to map out the texture or how you want it graphed on your your image. They need it to match. So I'll take this, which matches my vertices already right here. Makes sense, makes sense. Oh, yeah, it does. Wait, no, it doesn't. That's a lie. Let me change this to 0. What the? Maybe I just didn't read it right, because I'm an idiot. Wait. Oh, wait, never mind. I'm not an idiot. It's okay. Maybe I should take my time and actually read the article and understand what's happening instead of speeding through it in order to get this done. Because this will work in the long run. So we have a texture coordinate associated with them that specifies what part of the texture image to sample from. Fragment interpolation then does the rest for the fragments. Okay. Texture coordinates range from 0 to 1 in the x and y axis. Remember that we use 2D texture images. The texture coordinate using coloring coordinates is called sampling. Texture coordinates start at 0, 0 for the lower left and 1, 1 for the upper right corner of the texture image. The following image shows how we map coordinates to the triangle. Okay, so we kind of go down to the triangle scale, like in its matrix. Like this is the window matrix, 0, 1, 1. Then this is the triangle. Then we have the triangle inside this matrix, and I guess textures we jump down into the triangles matrix, which is 0, 1, 1. So we jump down this little square right here. That makes sense.
Delaney?
Oops. Okay, we specify 3 texture coordinates for the triangle. We want a bottom left of the triangle image to correspond with the bottom left side of the texture, so we use 0, 0 texture coordinate for the triangle is bottom left vertex. The same applies for the bottom right side of the triangle, and this applies for the top with the center of the texture image. So we take 0.5, 1.0 as the texture coordinate. We only have to pass 3 texture coordinates to the vertex shader, which then passes those to the fragment shader that neatly interpolates all the texture coordinates for each fragment. The resulting texture coordinates would then look like this. Texturing sampling has a loose interpretation and can be done in many different ways. It's thus our job to tell OpenGL how to sample its textures. Okay. So we have texture wrapping. The texture coordinates usually range from 0 to 1 or 0 to 0 to 1 to 1. But what happens is if we specifically coordinates outside this range, the default behavior of OpenGL is to repeat the texture images. We basically ignore the integer part of the floating point texture coordinate, but there are more options OpenGL offers. GL repeat, I don't really care. Each of the options have a different visual output when using texture coordinates outside the default range. Let's see what these would look like on a sample texture. GL repeat. Okay, so if we go out of bounds, it will just keep repeating. GL mirrored. Okay. Oh, that's actually, whoa. Okay. Each of the aforementioned options can be set per coordinate axis, S, T, and R if you're using 3D textures equivalent to X, Y, Z with the GL text parameter pointer function. This first function specifies that the texture target we are working with is 2D textures, so the texture target is GL2D. The second argument requires us to tell the option we want to set it, and for each texture axis. We want to configure it for both this S and T axis. The last argument requires us to pass in the texture wrapping mode we'd like in this case, OpenGL will set its texture wrapping option on the currently active texture, which is GL mirrored repeat. If we choose the GL clamps and border option, we should specify a border color. This is done by using the the equivalent of the GL texture parameter function with the GL texture border color, as it's the option we pass in a float array of the border's color value. Okay. Basically what I'm getting at is if we have to do that, it's gonna, if we do go out of balance with the texture we're trying to map it to, we will set it to like a typical fragment color vertex, and that's what would happen. Texture filtering. Texture's coordinates do not depend on the resolution, but can be any floating point value. Thus, OpenGL has to figure out which texture pixel, also known as a texel, to map the texture coordinate to. This becomes especially important if you have a very large object and a low resolution texture. You probably guessed that now that OpenGL has options for this texture filtering as well. There are several options available, but for now we'll discuss the most important options: GL nearest and GL linear. GL nearest, also known as nearest neighbor or point filtering, is the default texture filtering method of OpenGL. When we set GL nearest, OpenGL selects the texel that center is closest to the texture coordinate. Below you can see 4 pixels where the cross represents the exact texture coordinate. The upper texel has its center closest to the texture coordinate and is therefore chosen as a sample color. GL linear, also known as bilinear filtering, takes an interpolated value from the texture coordinate. Neighboring texels are approximating a color between the texels. The smaller the distance from the texture coordinate to the texel's center, the more the texel's color contributes to the sampled color, before we can see that a mix of color of the neighboring pixels is returned. But what is the visual effect of such texture filtering method? Let's see how these methods work when using a texture with a low resolution on a large object. Therefore, textures is therefore scaled upwards and individual textures are noticed. GL nearest results in blocked patterns where we can clearly see from the texture, while GL linear approaches a smoother pattern where the individual pixels are less visible. GL linear produces a more realistic output, but some developers prefer more 8-bit look and as a result pick the GL nearest option. Okay, I should probably take some notes on this, which I'll do in a second. Actually, I'll just take it on my laptop. Okay, that all makes sense so far. Texture filtering can be set by magnifying and minifying. Oh god, why is my laptop so bright? Turn that down. Texture filtering can be set as magnifying and minifying operations when scaling up or downwards. So you could, for example, use the nearest neighbor filtering when textures are scaled downwards, and linear filtering for textures scaled upwards. We thus have to specify the filtering method for both options via GL texture parameter. The code should look similar to setting the wrapping method. Minimaps. Imagine we had a large room with thousands of objects, each with an attached texture. These objects will be far away that have the same high resolution texture attached as the object closer to the viewer. Since the objects are far away and probably only produce a few fragments, OpenGL has difficulties retrieving the right color value for its fragment from the high resolution texture, since it has to pick a texture color for a fragment that spans a large part of the texture. This will produce visible artifacts on small objects, not to mention the waste of memory bandwidth using high-resolution textures on small objects. To solve this issue, OpenGL uses a concept called mini-maps. That is basically a collection of texture images where each subsequent texture is twice as small compared to the previous one. The idea behind mini-maps is it should be easy to understand. After a certain distance threshold from the viewer, OpenGL will use the different mini-map texture that best suits the distance to the object. Because the object is far away, the smaller resolution will not be noticeable to the user. OpenGL is then able to sample the correct pixels, and there's less cache memory involved when sampling that part of the minimaps. Let's take a closer look at what a minimap texture looks like. Creating a collection of minimap textures for each texture image is cumbersome to do manually, but luckily OpenGL is able to do all the work for us in a single call to GL generate minimap. After we created a texture, when switching between minimap levels during rendering, OpenGL may show some artifacts like sharp edges visible between two minimap layers, just like a normal texturing filter. It is also possible to filter between minimap levels using nearest and linear filtering for switching between minimap levels. To specify the filtering method between minimap levels, we can replace the original filtering methods with one of the following 4 options. Alright. Just like texture filtering, we can set the filtering method to one of the 4 formed methods using GL text parameter I. A common mistake is to set one of the minimap filters options as the magnifying filter. This doesn't have any effect since minimaps are primarily used for when textures get downscaled. Texture magnification doesn't use minimaps, and giving it a minimap filtering option will only generate an OpenGL invalid enum error code. Loading and creating textures, the first thing we need to do is to actually use textures to load them into our application. Texture images can be stored in dozens of file formats, blah, 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 blah. I understand that. We like to use PNG and write our own images to convert the image formatter into a large array of bytes. While it's not very hard to do to write your own image loader, it's still cumbersome, and what if you want to support more file formats? You then have to write an image loader for each file format you want to support. Another solution, and probably is a good one, is to use an image loading library. Supports several popular formatting options and does all the hard work for us, like STB image. Okay, I think tomorrow, as just a fun little exercise, I will do that myself. How to take a PNG, and turn it into bytes of data in C++. Is that a real thing? It's not a real thing. Okay, I'm an idiot. I'm getting sidetracked. No, I don't care about that. Yeah, because he's using a library. I don't know why I didn't read it. I should have just read it and realized, but it's okay. It's a very popular option, single header library image using by, who's this guy? Is he famous? He's not famous. But he is famous for his library, but let's see this is able to pop in formats can be downloaded here. Simply downloading it, a single header file as STB image can create an initial C++ file with the following code. Give me you. Give me you. How does he do it? Okay, I understand, bro. Holy crap. Half of this is comments. Whatever. That sounds like a really fun exercise. I want to do that. That'd be pretty cool. But time to make our thingy. Header. Oh, why did I name it header? I'm a fucking idiot. And I did CPP. Go. Add new item. STB image. It's just STB underscore image. dot h fat dump and then we gotta create that CPP file. With this. There you go. Okay. By defining STB image implementation, the processor modifies the header file such that it only contains the relevant definition source code, effectively turning the header file into a CPP file, and that's about it. Now simply include STB somewhere in your program and compile it. For the following texture sections, we are going to use the image of the wooden container to load in an image using STB image with the STB load function. Alright, compile. Let's see if I get any errors, please. No errors. We still got that pretty triangle. And let's include our image. STB image. And let's see what happens. There we go. Okay. Let's create this little section right here called image stuff. After we get the textures done, then and the GLM stuff, I will organize all my stuff. And the image stuff. We don't need the image stuff anymore here. And let me actually create a region. Just stop this. What? Why? Take all this, slap it in here. Shut that. There you go. You know what? I can just include this too in here. I don't really care. There you go. I'm gonna stop. Alright, that's more neat, more manageable. For the following texture entries, whatever. Alright. JPEG. Are you serious? Did I save a JPEG? Or was the first image not a JPEG? We're about to find out. Oh, it is JPEG. Alright, we're chilling. Whatever. Alright, what was it? STB load or something? Let's figure it out. So, int width, int height, and int end channels. What does that mean? In our channels. I don't know what that means, but we're about to figure it out. And then we create an unsigned char pointer of data. This will be what I name it? Wall. The function takes an input of the file location. It expects you to give 3 ints as the second, third, and fourth option. That STB image will fill with the result image's width, height, and the number of color channels. We need the image's width and height for generating textures later on. Generating a texture. Like any previous objects in OpenGL, textures are referenced with the ID. Let's create one. Okay. So here we loaded our data. Now we have all our data, and we loaded that image up. Alright, now let's create our texture. A texture, and then we pass in GL, gen textures, and we pass in one. We want one texture, and here you go, pass in that ID. So you can write to it. The GL gen texture takes an input, textures how we want to generate, and then stores them in an unsigned int. array given its second argument. Like any other objects, we need to bind it in a subsequent structure command, which will currently look like this. Okay, I'm just gonna copy it. There's no point typing it. We're gonna bind our texture to a GL type. Now the texture is bound, we need to start generating a texture using the previous loaded image data. Textures are generated with GL image 2D. Okay. So we generate a 2D image, pass in whatever, I don't know why you're passing that. 0 GL RGB with height, 0 GL RGB unsigned byte data. What does that mean? We're gotta figure it out. And then we generate our mini maps, which makes sense. I understand that. This is a large function with quite a few parameters, so we'll walk through it step by step. The first argument specifies that the texture target, we're setting it to a GL texture 2D, means the operation will generate a texture on the currently bound texture object at the same target. So any textures bound to target GL texture 1D or GL texture 3D will not be affected. The second argument specifies the minimap level of which we want to create our texture for. If you want to set each minimap manually, but we'll leave it alone, which is the base level, which is 0. The third option tells OpenGL what kind of file we want to what kind of format we want to store our data. Our image just has only RGB values, so we'll store the texture with RGB values as well. The fourth and fifth argument sets the width and height of the resulting texture. We store those earlier when loading the image, so we correctly corresponding variables. Next argument should always be 0, some latency stuff. Seventh and eighth argument specify the format, data type of the source image we're using. We load the image up with RGB values, store some chars, bytes, chars, s, which is necessary bytes, so we'll pass in the corresponding values. The last argument is actual image data. Makes sense, makes sense. The last argument is actually image data. Once GL text image 2D is called, the current bound object now has the texture image attached to it. However, currently is only has the base level of the texture image loaded, and if we want to use minimaps, we have to specify all the different images manually by continuing incrementing the second argument. We could call generate minimaps after generating the texture. This will automatically generate all the required minimaps for the current bound texture. After we're done generating the texture, it is corresponding maps. It's good practice to free the memory. Okay. Here you go. Goodbye, data. You're free. Okay. So we need to do all this stuff. And then free it after. Alright. So basically, we're passing these parameters. We're saying, hey, wrap here, and repeat. Texture min filter, texture linear. And I would have to reread all that to really remember it, but I understand the basic idea of what they're telling me here. I told you to do that. What? What the fuck? Oh, fuck. Oopsie. This needs to go right here. Okay? And this needs to go not right here. First, we get our texture, we generate it, and we bind it, right? Boom. Then we tell everything. We tell how we want our texture to work. Then we load up our image. And then we generate our 2D image and generate our minimaps. Our minimap. And then we say if it failed. And then at the end, when we're done with all that, we just say, hey, get out of here, data. We don't need you no more. And it's gone. So now we can actually apply our texture. So let's just run it and see what happens. Hopefully I don't get an error. If I get an error, I'm going to quit and give up. And I get an error. Okay, why'd I get an error? Huh. What happened? What? What just happened? Oh. That's not how we write code here in this house, buddy. Yeah, no error. Okay. but I am consuming so much memory. Oh my god. 82,000 kilobytes. That's crazy. Applying the textures. For the upcoming sections, we will use the rectangular shape drawn from GL elements. The final part. Alright. That's dumb, okay? That's dumb. I'm not adding the damn colors, okay? On my vertex points, okay? There's no need to do that. There's no need to interpret. There's no need to do that, okay? There's no. My frag color will do that for me, alright? You stupid idiot. Stupid. I will add my texture coordinates, though. That is fine. Wait, but I already have my texture coordinates right here. Whatever. Alright, so this is my bottom left. Lower left or whatever. My lower left will go here. And my lower right, which is this one, will go here. And my top one will go right here. There we go. So now I can just delete that. And then like tab this over a couple bit. And we can just say texture coord. And then now we have to tell our UV or pointer how to actually read our data. Yay! With our strides. So now we need to actually pass in the color point. So we gotta generate another fucking GL pointer, which is fine. I'm not angry, but a little. GL vertex array. What is it? GL gen pointer vertex pointer or something? Or attribute pointer. Attribute GL gen attribute pointer. Vertex attribute pointer. Okay. This is our second index. Right, if I go back to here. Yep. We're passing in two floats. We're passing in. GL float. GL false. The stride is like, oh, I'm gonna have to adjust everything else too. 1, 2, 3, 4, 5, 6, 7, 8. This new stride's 1, 2, 3, 4. This is 4. Times 4. And I need to go up here and tell it that it's 4 too, or I will get errors. You need to increase the 4, buddy. Sorry, I know you're sad about that. It's okay. And we need to start like 2 deep or something. 6. 1, 2, 3, 4, 5, 6. Yeah, we need to start two floats in. I remember that. The only reason why I remember how to do this is because what I did was I speed ran doing a triangle one, and it made me force myself to actually understand how everything worked. And why aren't you working? What? Okay, size of float times 4. Oh, I got cast to the avoid pointer. Sorry. Stop yelling at me, bro. I did what you wanted, okay? Stop. I got you. Stop. You're annoying me. Void pointer. Expression must have an increment. Oh, you're making me angry. Oh, that's why. There you go. What did this spit out to? What value did this spit out to? Will it tell me? An 8. Oh. So an 8 unsigned unit. Alright. And then we got to enable it. GL enable vertex should be away. We got to enable our first one, right? Yep. And then we got to go into our shader, which we have to do. Which shader we have to do? Only the vertex? We got to do both. Okay. So this is our vertex one, and we just gotta pass in our layout location equal to 1. We gotta take a vec2 called Why am I passing in a vec 3? This is a vec 2. Good thing. What the hell? Stupid me. And we gotta pass in a text board. And we out our vec2 called O text board. O stands for out. I don't know why they do that, but I'm just gonna follow along. I don't care. O text chord is equal to A text chord. Then we go into our fragment. We have to take in a vec2 called O text chord. And we need to pass in a uniform called sampler 2D, and this will be our texture. And then we need to say and then basically instead of passing in these colors, so goodbye beautiful triangle, I'm sorry that you have to go, it's okay, I miss you and everything. We have to basically say texture our texture and our O text chord, right? Our texture and O text chord. Okay, and then right every time we render, we have to bind it. So boom. And then bind that texture, which I'm pretty sure it's already binded, but I don't really care. GL2D texture, I'm pretty sure that's what we passed in. Yeah, whatever, just copy it. Okay. There we go. Alright, let's see if this worked. Okay, so my shader broke. Okay. Okay, let's not free the message. How about that? I don't care. Okay. Too little data in type constructor. Maybe, all right, let's see the source code. GL triangles 0 to 3. Okay. 2. Bind the vertex array. Let's see what I did wrong. Okay, it didn't fail to load the textures, right? So what did this look like? Geo bind. Okay, so bind the texture before we call our shader. And now let's see what happens. Still not working. Too little data in type constructor. Wall.jpg. Okay, it's here. Here's our wall.jpg. Now I'm passing in our wall.jpg right here. You know, the solution is just to copy this error message and look it up. I'm not using GL points, but it's okay. Are these not? I thought I was giving 4 components. I guess I wasn't. I guess I'm only giving 3 or something. But I'm pretty sure these are both vec 2s. Let's see what happens. Nope. Too little. That's it. I'm gonna add one more because I'm crazy. See what happens. I'm just gonna try to overload it and see if they get mad. Yeah. Now okay. Now I got mad. Overload. Okay. Okay. Well, I never passed in that uniform, so what the? Why the hell would I be using a uniform? You know what I'm saying? Like, I never actually passed in a uniform, so that uniform is blank. Generate a texture, you make it a 2D. I did that part right. And then I did that part right. I freed the data. Then we go down to here. I find my texture and then I render it. I did that part right. So let's go to their shader thing. Very complex for no reason. Again, very complex for no reason. Can I please go to like the shader source or something? You stop doing that. Here we go. Vertex and the frag. So he says texture 1. Pass in a text chord and a texture 1. But I never said that though. But okay. That's fine. How about I say, and then he says what? frag color. We pass out our O text cord, right? Take in this, right? That data successfully goes in. Then I pass out a thing called O text cord. I go over to my fragment, and we see. All right, that's it. We take in something called revec2 text cord. Okay. And in our vertex, we pass out something called a text cord. And here we take in a text cord. So in our fragment, we say text cord is equal to a text cord, which is what we take in right here. Then that gets outputted. We take this in right here. We make a uniform right here. And then our main, we say frag color texture is equal to that. But we need to output our vec for frag color. So we do that too. But now that I'm doing that, nothing should be rendered still. Too little data in constructor. I mean, I'm following it. Gotta go the old-fashioned way. It worked. Yeah, woo! I don't understand how it worked. What the fuck? What? What was I doing wrong? Good thing I'm live streaming all this so I can look back. Yes, sir. Okay, let's look back. Okay. What was my problem? Yeah, let's go, bro. Textures in OpenGL, bro. I never thought I would be able to do that. Actually, that's a lie. I knew I'd be able to do it. It was just kind of daunting, and that was really easy. I'm saying that after I failed to do it for like how long was that? Let me see how long I was doing that. Bro, I spent like 40 minutes doing that. That's crazy. And I spent a long time. I spent like 17 minutes debugging that, bro. Oh my god, dude. But why? Why wasn't that working? Let me see. That's the old fact. You know, I always see people on chats and stuff. They're like they talk about how they copy and paste from Stack Overflow and stuff, and I'm like, and I always shame people when they do that. I always shame people when they do that, right? And then I just realized that I did the same thing and it worked, you know. So at the end of the day, we're all victims, okay? We're all victims to poor code, and you don't understand how it works. So, you know, sometimes you just gotta copy and paste, you know. Let's go. That looks so nice. What a nice texture. Textures. Yes, sir. Yes, sir. Oh, yeah. Alright, now it's time to compare on why that didn't work. Uniform sampler 2D, that's correct. Yep. Frag color, yep. We output the frag color, yep. We take a text chord in, yep. Oh my god. Never mind. I thought I figured out why I did it wrong, and I don't, so I'm not gonna. I was about to say, oh my god, I'm a dumbass, but no. So we take the in-text chords the same way we spell over here. We out of Vec2, call text chord, take that text chord in. Okay, that's spelled right. I don't know why that wouldn't have worked, but proceed on. We take a Vec2, we got a position. So text chord is equal to A. Okay, I have no idea why that didn't work. I'm just gonna be straight up. Because I thought I had the same thing. I'm reading it back. So I'm just gonna wait. Let me rename everything. Let me rename everything so I can actually see the difference. This is a text chord. We output a text chord. This needs to be changed to a pause. This is now output text chord with a text chord. Alright, and then we go down to this one. We're taking in a text chord. Our texture just gets turned into texture 1. So texture 1 text chord is text underscore chord. Oh, let's see what happens. Worked. Okay, so now I can directly compare what the hell didn't work. So correct. GL frag chord is equal to texture 1 text chord. Correct. Okay, so my fragment shit is correct. Now let's go back over to here. Correct. Yeah, that's good. We out something called text chord, which we do. That's correct. Void thing, GL position, right? Text chord is equal to A text chord. What the the only thing I could think that the reason why it didn't work is because everything was crammed together like this. It's the only thing I can think that's why that didn't work. Unless I'm missing something obvious. No, I don't. Okay, I have no idea why that didn't work, but you know, sometimes they're just losing battles. That makes no sense. What the fuck? Are you serious? Text chord, this, text chord, that. Okay, I understand. Okay, I'm not gonna question it anymore. We're done. We're done with textures. It's over. Textures are done. Easy. I'm not looking at this again. Stupid brick wall, bro. What's our timer at? Textures are done. So what is the next step, you're asking? Well, it's to work on importing our math library, which shouldn't take too long. Working on perspective / GLM. We're working on matrix math / GLM. But I am going to stop the timer because I am going to take a quick break and celebration. Alright. Alright. I'll be back in like 10 minutes or something, or 15. Just gotta make myself some food, you know, celebrate textures, because that was pretty fire. I didn't do that. But you know how it is. Yeah, you know, I did textures. That's pretty cool. Pretty happy about that. And yeah, so I really want to get 4 hours of programming in before I take another break. Dude, I don't know. I'm able to finish this in 72 hours, but you know, we're gonna try. And keep in mind that the timer up there is just my work session. I should probably change that name into like current work. Work timer. Move that back like to there. Work timer. There we go. Because honestly, I don't think we'll be able to complete this in time. But who knows? We got textures done. And now we just gotta work on the matrix math, and then after that, we gotta just organize everything. We just gotta organize everything, and then we're good to go to make the player, which shouldn't be too hard. Just get some movement down. And maybe animations. Maybe we should tackle GLM and then animations. Or like just a basic idea of how to deal with animations, and then after we do that, we go and we try to make our thing work. Because if we do that, if we you know, half of the animation systems tackle with the textures, okay? So that was my main concern. I think what I'm just going to try to do, if we go back to my goals right here, I think I'm just going to try to do one boss fight, but really good everything. Just feels really good. I think that's definitely more achievable compared to this goal right here. So I think this could be achievable. So I think I'm just going to focus on this. And if I have extra time, I'm going to try to do this and that. I think that would be a good idea. But right now, I am going to take my break. So, I will be back. Okay. That was a bit longer than I expected. But you know what? That's fine. That is fine. Alright, 1 second. I'll be back. 2.5 seconds. Alrighty, right. I got 1 more hour and 30 minutes left in this work session. Trying to do a healthy 4-hour shift. I've been live for 3 hours. That's a success, I guess. Alright, so we need to work on, what was it? Math? Alright, it's math time. It is math time. Let's see that JPEG one last time. Beautiful. Beautiful texture. Now it's time to get GLM. What? Right here. Alright. Download zippy zip. Oh, I already have GLM installed. Nah, it's okay. I don't care. Alright, we just need this. Go to our VS Code. And then go to Properties, General. It's in right here. Oh wait, well I don't need to do that because I already have my include folder. So now I should be able to do. There we go. I should be able. Oh, I didn't start the timer. All right. Okay. Now it's time to get the basic translation down, which I know how to do, but I'm just gonna follow what's its face. GLM is installed. Let's actually run it real quick to make sure I did it right. Sure, bro. Oh no, I didn't. What I did? didn't? Oh, yeah, I was about to say. What the hell? I was like, how did it just compile if I just fucking... If I just apparently didn't use it correctly. Alright. I understand how all this matrix math works. Stop it. Don't tell me it. I already know. I've already read through this whole thing. I will take the time though to actually learn it. But GLM will handle it for me. Okay, here are my GLM files I'm gonna need. And here is this transform I'm gonna pass into this shader. So in my vert shader, is it my vert shader or my frag shader? It's our fragment shader. Yeah. Alright, so our vertex shader, we will no longer have to touch anymore because it is donezo. But we will have to attack our fragment shader because we need to tell it how to actually translate our textures. So uniform called uniform map 4 called transform. Actually, you know what? I'm just gonna take this from my current project. It's not like I need it. I don't need to read this word for word, to be honest. Where's my shader? Go. Alright. I'm a player. Player simple. Player's too simple. Oh wait, no, it's the vertex shader I have to pass everything into. Right? Yeah, vertex. I don't know why I thought it was a fragment. I'm a dummy. It's very peaceful out. It's raining, you know, just tapping away. Trying to get this work done. Feels nice. You know? That's what I like. Alright, here we go. Let's get this knocked out. Let's get this done. Let's speed up the progress. There's no more learning anymore. This is just shit. Oh. This is just stuff I already know how to do. I've done it before, I've done it many times. Let's make our model, our view, and let's make our MVP. Okay. And now we also have to declare our aspect ratio. To go up here to our aspect ratio. Mike, get out of the way, please. U32. U32. Screen width. equal to 800 u32. There we go. And then our aspect ratio Jesus, why is my... Oh, I was at an awkward angle right there. My wrist is hurting, like, really bad. Right, there's a little aspect ratio set up. Oh, I'm so sorry. If anyone watches that back and hears me throw the mic, I'm so sorry. I did not mean to do that. Oh God, reading all this old code. Reading all this old code sucks. Model times view times projection. Model times view times projection. That's what it is. Model view, GLM translate. Change that view. We scale with the model. Our MVP is equal. Alright, so our projection is equal to stop GLM mat4 projection is equal to GLM mat4 and then we take our projection, make it equal to GLM ortho because we're using a 2D perspective, negative half our width, and then half our width again, half our height, half our height again, 2, 3, and 1, 2, 3. There we go. And then that's our projection. I also have to write a nice little function right here to pass in shader uniform mat4. We take in our shader, and then we take in the name, and then we take in the actual value. So I have to include the math up here, which is fine. Okay. Void. GL. It goes. You gotta find the location, so we use our GL. GL set or GL shader set shader or it's GL uniform or set uniform, right? Set uniform. Oh no, it's just GL uniform. GL uniform 4M or M4 matrix 4 FV of our GL get uniform location of our shader at their name at our 1 GL false and our matrix or our GLM value pointer matrix. There we go. So now we go over to here and mess with our shader. So right now in our player shader, we have it getting translated. So let's do the math. So when we scale, we use model. So I want my model just flat at 0, 0, so we don't have to translate our view, but our model, I want to scale it like a little bit up. So view is equal to GLM scale our view by, let's make it 100F, 100F, 0 to 0F. What? Why are you angry? I give you a matrix. I give you 3 floats. I know I don't have to put it in GLM. Huh? Oh wait, why am I saying view for scale? That would have fucked everything up. It's our model, too. So our model is equal to our model. Oh, I do. Whatever. Times that. And then our MVP is equal to our model times our view times our projection. It's almost like MVP stands for that exact saying. Actually, it doesn't. Projection gets multiplied first. Sorry. That would have been wrong. Don't ask me why it says that. Unless I'm the idiot, but I'm not. Shader set. Shader set. What'd I name it? Oh. That's why. I didn't name it. Shader uniform set. Shader uniform set. Shader uniform set matrix 4. Pass in our shader. What I name it? Like basic shader or something. Shader basic UMVP. And pass in our MVP, that is what I called it in my vertex shader, and I should set that every. Oh shit! I should set that every frame. Every frame, set that. That should work. Hopefully it does. So I'm gonna be really upset if I have to fucking debug it, bro. And it worked. Yes. Yes, yes, yes. And then if we, let's go. And then if we want, and then we check if GLFW key pressed, or like press key GLF. What is it? What is the key press? And it's like it's like check press. If check press. I don't know. That's a function I made. If GLF key Oh, get key. GL. I have to pass in the window, and then GLF. I never understood why I had to pass in the window. Then, oh, I don't want W. I want like D. If that is the case, then we take our view and we do a little translation of our view by like I need to move the X positive. Alright, let's see what happens. Oh. Oh, is it moving? I don't think it is. I don't think it's moving. I know why, though. Think I know why. This should come out as true. Good. Good, we know it's working. So what's the problem, Doc? What's the actual problem? Please let me go to my multiplication so I can see where I multiply this. That'd be very nice of you. Where's my render function? Here it is. Ew, my font's so ugly. I like this font. Oh. I never dealt with movement like that. Oh wait, I do it here. Old code, love looking through. Let me try something. If we plus this, every time we run our view. Oh, you know why? I'm a fucking idiot, bro. Holy shit, I'm so stupid. And I'm cursing because I'm so dumb. We have to do that, dude. I'm not readjusting my multiplication, dude. That's why it wasn't working. Hell. Of course it's not gonna work if you're not multiplying everything. Stupid. I don't need to reset my projection. I just need to reset these things over and over and over again. Every time we run, we do that, and then every frame, we can also scale it, which I will do down here. Scale it, and every frame we move 1.f. That's why I wish I used Unity. If I didn't program this from scratch, it'd be so much easier. Now it should move. Yeah. Every time I press 1, it'll go bloop, 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 bloop. Easy. But let's put in this X value, and every time actually what's going to happen is this view is always going to get multiplied by right there. And then X is going to be plus equal to by 0.1f. Now we should have some fluid movement. There we go. And then minus, and here we go. Easy. There we go. OpenGL movement, baby. And let's finish it off with the up and down. So this will be set to the y minus, I think no, it works off the 0 zeros at the bottom left. Alright, see what happens. Oh, that's why. Wait, what? Oh, because I'm not translating by y. There you go. You can go bye-bye, Mr. Laptop. Yeah. Yes, sir. Oh, whoa. Very laggy. I need to implement some delta time. Yes. Isn't that so amazing? Crazy. We have movement with OpenGL. It is time to move on to the next task, which is organizing our next work. That is done. Now we need to organize to I don't know how to spell organize, bro. I'm so stupid. Tidy, titty, no. Or organize. There we go. Alright, we're working on the organization of our project. Let's actually get this thing laid out and structured, so it's not a big fat mess like it is right now. This is terrible. This is actually terrible. Oh, God. Because ain't no one want a really broke project with nothing in it. Alright, 2 hours and 50 minutes down. About to hit the 3 hour mark, so we're about to push for the final hour of this session. And then I'm going to take a fat break. It is 1:30 in the morning. It is 1 in the morning after all. So, you know. But I need to get this work done, because tomorrow, or whenever I work on the project next, I want to be actually being able to implement basic gameplay features. So I'll be right back once I need to grab something, and then we'll be good. We are back, baby. Time for the final push. The final push. The organization part. Alright, let's get this done. Alright. Let me update the thumbnail because we have made progress, which it is not technically the most valuable use of my time, but who cares? I think we're around like right here. I think we're around like 10% done. There we go. Alright. Got a little snack. I changed the thumbnail. Let's get this done. Alright. Okay, so this is basically OpenGL stuff. This is just texture stuff. I think I should organize textures. We're basically going to use this kind of texture format all the time. We can see that with, like, right here. We are definitely going to use this texture format all the time. And let me make an actual thing to, you know, adjust our textures. I kind of hate jumping around between all this stuff, so I think what I'm going to do putting this all in one file would be such an idiotic decision, but I'm really tempted to do it because I hate adding new CVP files and everything. Alright, here we go. Texture. Alright, render. So let's get that down. Let's make this a struct called texture. Let me capitalize that. Texture. We need to Okay, right now there's no use in actually doing this, so what we're gonna do type def unsigned in called texture, Because honestly, there's no reason for us to do that. We can just pass in the texture because there's no struct, there's no other data we need to keep track of. It's fine. So we have init a texture. Let me pull up my source file right here so I can just compare. Alright. So if we want to generate, let's do void or init. Alright. Let's pass in our texture or pointer, call it texture. Okay. And then we need to pass in the counts. We need a int called texture type, int called how about right now, let's put a comment above this. Manual one set way of initting textures could change in future. Because honestly, I'm not making a game engine, or at least I'm not making a commercial game engine, so it doesn't really matter. What I do. I don't need to make a fat function to determine whatever and pass in all the possibilities to render a texture, because it's not that big of a deal. I'm only going to be focused on 2D textures in this one style. Alright. There we go. Alright, here we go. Now, this is all simplified into this one nice little simple file. All I have to do is do include texture. I can block that out. I don't really need to. And I can just go down here. Oh, I need to make that. I don't. Yeah, I do. Oh, I need to change this to texture slash init, texture slash bind, and then pass in our texture. We don't really need a pointer to that address. I'm running up here. I'm gonna capitalize this. Okay, what's your problem? Okay. So why is this not working? Oh. Texture in it. Texture. Hello? Why did everything just break? Oh, that's why. I was wondering, I was like, it's not auto-correcting. Why isn't it auto-correcting? And then I just finally realized why it wasn't auto-correcting. Because something was broken. There we go. Alright, see if it worked. Yep, it worked. Alright, so nice little refactor. So now all I have to do to create a texture is just say this, say texture, and then do texture.init, and I can create a texture whenever I want, and then adjust a attribute pointer. Oh, stop squeaking, dude. So that's pretty nice. So that's our textures organized, our shaders are organized. And I think it's just now it's just time to honestly get into some game dev shit. We spent 3 hours setting up OpenGL, textures, math, which in reality shouldn't have took that long, but I had to learn how textures work, and then I haven't done this in like a month, so next time it'll be a lot faster. But at the moment, it wasn't really that fast. And also at the start of the stream, I was trying to fix issues related to stuff, and then I took that fat break to eat food, which was really long, but whatever. Alright, so let's sort this out. So we know we're gonna need a player and we're gonna need like an entity, because right now our goal is just to get what am I saying, bro? I don't know, bro. I'm kind of tired, so I'm just gonna stop and just get to work. I'm gonna make global data. I know that's a bad idea. People hate on it, but I don't care. Oh, I need to include GLFW. That's our global data done. Alright, here we go. Time to make the player. That's cool. I didn't know I could do that. Oh, sorry. This is my fighting game. Wow, what a great fighting game. It's just a square that's just as a brick. Not a square, it's a triangle. Just as a brick. Wow, what a great fighting game. Oh, this can't be. Okay, that's all that set. I need to make this shader, which I'll do. It's fine. Alright, I'm gonna have to include global. Left, top, right, top, right, top. we want to use. Do they start at the ones or zeros? I don't really remember. Actually, I can just look. Oh, never mind, I can't. So we start bottom. Oh, first triangle is gonna be bottom. Bottom. Bottom right. And then we want to do top right. So let me just reorganize this. Oh, that's gonna be so annoying. I don't give a fuck. And then so bottom boot boot, and then I want to do bottom this. And then I declare EBO. EBO. Element. Oh, element. Now I have to create. Do I have to create my own vertex pointer for this? Please tell me I don't. I don't want to do that. It's so annoying. I do. I don't. I'm just. So here are my vertices, here are my indices, I match the texture chords, I declare all that. Good. I'm initializing all of the OpenGL stuff, and then I put my position and my texture. Now we gotta render. Oh, I need my shader. I forgot the shader. All these need to be static too, because I don't want to call these from outside files, just in case that ever happens. Then what we need to do, first step, is do this. Bind our texture. Program our shader, which we don't need to pass in because we're keeping it in this file. Fuck. Oh, because I'm not applying that actual pointer, because there's no need to do a pointer. What's geobind vertex array? Guess he unspines it or something. I don't really care to do that though. GL draw elements, triangles. We're drawing 6 indices. They're unsigned in. No, you started 0. Alright. That looks good. And now what I can do is like literally delete all this. Oh wait, you know what I need to do? I never created my my texture attribute pointer. Oh crap. Yeah, I actually do need to. Actually, no, I don't. It's fine. I I think it's fine. Alright, we should be good. I think I'm just gonna take this. And now delete all this. Oh, I forgot. I deleted my buff. Alright, now we can just go down here. Wait, did we include player? Have not. We don't need to include global anymore, buffer or shader, because our player covers all that. Now let's just go down here, say player, called player. Alright, hopefully this works. What a great sign. The fuck? Global guy, get. I'm not declaring. Wait, I need to make this inline. And it worked. Let's go. That's pretty easy. All right, nice little refactor. And there we go. Nice little refactor. Okay. Okay. It's going smooth. It's going smooth. Okay, and since this game isn't really, oh well, you know, we not really. All right. Now we can switch the task to collision. Alright. Let's see what happens if I like do something like that. That doesn't look right. That's not right either. What happened? Well, first we need to scale to size. So we want to translate about the X and Y. This needs to be set to F, but that's probably not doing anything wrong. Okay, so why is my translate not working? Pause equal to pause. So player, that's right. This should be right, and that's right. Okay. But as soon as I switch it, maybe I need to bind this right now. So we bind that, we bind this, then we use our shader, do our translations, and then go. It's a large movement. I think this is moving full scale. This is moving really fast. This is really weird. Why are these movements so large? It's moving like to scale of its original thing. Like the translation didn't work, you know? That's weird as fuck. Yeah, so this should not be moving that far. This is the last thing I'm going to fix, and then I'm done. Because this should not be moving that far. Should be moving like 5 pixels. This should be pixel length, not... yeah, this should be moving pixel length, and it's not. Why, though? We have our projection. Our projection's right, I'm pretty sure. Unless I hard code the projection, and then we can see that then, but... I don't know why it's moving that. Sorry for the squeaking, but why is it moving that large? Because I'm multiplying it wrong, that's why. I don't know what was going through. MVP for a reason, bro. Just MVP. There we go. That's right. I was multiplying it wrong. Okay, my matrix math was wrong. Yep. Alright, here we go. Alright, so tomorrow I can actually work on gameplay and collisions, or whenever I start to work on this next, which might be in a couple hours or something. I can work on collisions. So, that's pretty good. That's a big hunk amount of code that we wrote today. And, you know, it was pretty nice. Pretty nice, like, 3-hour, almost 4-hour session. But this YouTube video, this stream was like 5 hours long, 4 hours and 30 minutes, so, you know. But yeah, pretty good. We set up all the OpenGL backend. We learned how to do textures. I set up the basics of the player structure that we're gonna have to do. And now, tomorrow, all we have to, or whenever I work on this next, it's going to be more focused on getting the collision working. And collision, tomorrow we're going to get collision working, animations, and maybe the basics for the AI. I think that's a good idea. Because we still got a lot of tackle today. I mean, it was a small session. It wasn't even that large. It was just 3 hours and 46 minutes. But I'll come back to this later. The challenge started now. I have until Wednesday to do this. So, you know. But yeah, pretty good work. So, that is it.